Hi boys and girls, this is your full instructional video for lesson 140 and negative exponents. Up until now, all of the exponents we've been working with have been positive whole numbers, but it is possible to have 0 for an exponent and also to have negative exponents, and that's what we're going to learn about in this section. All right, this is on page 33 of your workbook. And your I can statement is I can use the 0 exponent rule and quotient of powers property to simplify expressions with 0 and negative integer exponents. So let's get started. Any number or letter to the power of 0 is equal to 1. Right? Now, most kids are like, no, sorry. But I can prove to you that any number to a 0 exponent is equal to 1. Right? The rule is, let me get my pen. Here we have the rule. You've got to write a 1 in this little box. Let me tell you why. All right, let's just take, for example, 3 to the third power. All right, 3 to the third power is equal to 3 times 3 times 3, which is equal to 27. Okay, 3 to the second power would be equal to 3 times 3, which is 9. And 3 to the first power, we all know, is equal to just 3. But the next one in the progression would be 3 to the 0 power. But kids often want to say that's 0. But let's look at this. To go from 27 to 9, we had to divide by 3. To go from 9 to 3, we divided by 3. So what's 3 divided by 3? That's right, it's 1. And it doesn't matter what number I start with, it always ends up 1. So that's why we have the 0 exponent rule. Anytime you have a number or a letter that is raised to the power of 0, it is equal to 1. Next page. Okay, so here we have our 0 exponent rule. Any number to the 0 power is equal to 1. There is one exception. They don't include 0 in that group. If 0 is raised to the power of 0, it is not equal to 1. It's still 0. All right, there's some argument over the whole 0 thing. So here's where they give you the proof, only they're using ends. You know, I use 3s. They're using ends. I think ends are kind of scary because of algebra, you know. So, but you can fill this out if you want. You would just have 4 ends here. This is pretty much the same thing as the 3 example. It's really small. Then you would have 3 ends, and then you would have 2 ends, and then you would have 1 end, and then you have 1. That was fun. All right. So write the expressions that are equivalent to 1 in the bin. Well, let's look at these. 2 to the first power is equal to 2. That's not equal to 1. 1 to the second power is equal to 1 because 1 times 1 is 1. Any number to the 0 power is equal to 1. Any number including 1 to the 0 power is equal to 1. 0 to the first power is just 0. And any number to the 0 power is equal to 1. So all of these are equal to 1. So any non-zero number to the 0 power, notice they say non-zero numbers because 0 doesn't get included in this. Any non-zero number to the 0 power is 1. So 12 to the 0 power is 1. They want you to simplify m to the 0, where m is not 0, it's 1. How much is anything to the 0 power? It's 1. Now let's talk some fun here. Now let's talk about negative exponents. Let me move this over a little bit. It's a little on the edge here. Negative exponents. And I'm not even going to really use this chart because, again, I don't really like their chart. I prefer my method of teaching this. Let's, instead of 3 this time, let's use 2. Let's say 2 to the third power is equal to 2 times 2 times 2, which is 8. 2 to the second power is equal to 2 times 2, which is 4. 2 to the first power is equal to 2. 2 to the 0 power we know is equal to 1. So notice what we've done each time. We have divided by 2, divided by 2, and divided by 2. But what happens if we go one more step? What if we go 2 to the negative 1 power? What's 1 divided by 2? Well, 1 divided by 2 is 1/2. Okay. What if we did it again? 2 to the negative 2 power. What's 1/2 divided by 2? 1/2 divided by 2 is 1/4. Right? And if I had room here, I could even go 2 to the negative 3 power. 1/2 of 1/4 is 1/8. But let's look at these. 2 to the negative 1 is equal to 1/2. 2 to the negative 2 is equal to 1/4. And 2 to the negative 3 is equal to 1/8. Or let's write this a different way. This is equal to 1 over 2 to the first power. This is equal to 1 over 2 to the second power. And this is equal to 1 over 2 to the third power. So what we're realizing here is that if you have a number or a letter raised to a negative exponent, you can make that exponent positive by putting it in the denominator of a fraction and putting a 1 over it. I know, mind blown, right? Totally cool. That's what they're trying to teach you over here. This is what they're trying to explain over here. This would be a tenth, a hundredth, 1,000, blah, 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 blah. Only in way more boring way. Okay. So any non-zero number to the negative n power is the multiplicative inverse of its nth power. Could they have said that any scarier? What they're telling you is that if you have a letter or variable raised to a negative power, you can make it a positive by putting it in the denominator of a fraction and putting a 1 over it. Likewise, if you have a fraction with a negative exponent in the bottom, let's say we have 1 over x to the negative 3, you can fix that by moving it to the top. Okay? Now you know there's an invisible 1 under here, right? Yeah. Okay. So what happens here is anytime you have a number to a negative exponent, if it's in the top of the fraction, you can move it to the bottom and it becomes positive. Similarly, if you have a number or a letter to a negative power in the bottom of the fraction and you move it to the top, it becomes positive. The movement going from top to bottom or bottom to top changes the sign on the exponent. Let's play with this. All right, example number 2 is on page 37. They've given you 6 to the negative 3. In order to make that a positive 3, you would write the 6 to the third in the bottom of a fraction with a 1 over it. Here they've given you a to the negative 5th power. So it would be 1 over a to the positive 5th power. Now, in order to fully simplify an expression, you must get rid of negative exponents. And that's why we have this process that we do so that we can write our answers with all positive exponents. Let's look at the next page. Example number 3. Now they've got that c to the 5th in the bottom and they're asking you to write it with a negative exponent. Well, if you have 1 over c to the 5th and it's in the bottom, when you move it to the top, it becomes c to the negative 5. Now we don't write this over the 1 thing, so we would just write c to the negative 5th power. Okay, so c to the 5th expressed using a negative exponent is c to the negative 5 power, which is not simplified. Express the fraction 1 over 9 to the 7th using a negative exponent. 1 over 9 to the 7th is equal to 9 to the negative 7 over 1. When you move a number or a letter from the top to the bottom or the bottom to the top, it changes the sign of the exponent. We don't have to write the over 1, so we can just write 9 to the negative 7. Number 4. Now they want to apply the properties of exponents to these problems. So here, let's see. They want you to use the product of powers property. They've got 5 to the third being multiplied with 5 to the negative 5. So I'm going to do that over here. If we have 5 to the third power being multiplied with 5 to the negative 1/5 power, or negative 5th power. When we multiply two numbers with like bases, we add the exponents. So this is going to be 5 to the 3 plus negative 5 power. Well, 3 plus negative 5 is negative 2. So it's 5 to the negative 2, but we can't leave our answer like that. That's not fully simplified. So we need to put a 1 over it and put the 5 to the second power in the bottom. So over here, you would have 5 to the negative 2. You would have 5 to the second. Oh, and then they want you to take it a step further and write 25. So we have a check down here. See the check? We'll do it in a different color so it stands out. We have 3 to the 9th times 3 to the negative 4. The power of the product of powers property says that we have to add the exponents when we're multiplying. So we would have 3 to the 9 plus negative 4. Well, 9 plus negative 4 is positive 5, so this is just 3 to the 5th power. Our answer did not end up having a negative exponent, so we don't have anything to fix. Okay, so negative exponents using the quotient of powers property. Okay, they've given us w to the negative 1 over w to the 4, negative 4. Now, I would be tempted to flip this, because if I move the negative 4, 1 up, it'll become positive, and if I move the negative 1, 1 down, it'll become positive. I'm going to do it both ways. I told you that you can move these from the bottom to the top, and you change the exponent, change the sign on the exponent. So you can move the w to the negative 4 to the top, and it becomes positive 4. And you could move the w to the negative 1 to the bottom, and it becomes positive 1. Or you can do it their way, where you go w to the negative 1 minus negative 4, and then you have to keep, change, and you would get w to the 3rd. But isn't that what you get over here? W to the 4 minus 1 is w to the 3rd. My way's pretty easy. Yeah, I think my way's easier. I like mine too. Especially if the top and the bottom are both negative. See, these two, just swap them. All right, put the 4th on top and the 7th on the bottom. All right, and then you have b to the 4 minus 7, which is b to the negative 3, and that can be written as 1 over b to the 3rd. Remember, we have to get rid of the negative exponent, so the way we do that is we move it to the bottom of a fraction and put a 1 over it. Sorry, this is so messy. Still haven't mastered the graphic tablet. Here I have several examples that I'm going to do just to show you. The directions on this is to write it with a positive exponent. Simplify and write with a positive exponent. This will be 1 over 4 to the 2nd power. This will be 1 over 7 to the 3rd power. Just move it to the bottom of a fraction, stick a 1 over it. Now here, k is to the negative 3 power, but the 2 is not. The 2 doesn't have an exponent, so it's positive 1. So what we do when we fix this, the k or the 2 stays where it is because it's positive. It's good there. Only the k needs fixed, so only the k goes to the bottom. Over here, we don't have any, we only have the 1 number, so 1 over x to the 2nd power. Okay, here number 5, we have a 7 that's to the 1st power, so 7's going to stay on top, and only the n is going to drop to the bottom. Remember, we don't write 1s. Here, to make this positive, you put a 1 over it, stick it in the bottom. This one, well, that's a lame example. It doesn't even have a negative exponent. We would go 5 times 3 times x to the 3rd times x to the 3rd. That gives us 15 x to the 9 or to the 6th. We add the exponents. All right, now we get into a negative one here. This will be 3 times 8 times p to the negative 3 times p to the negative 3. So 3 times 8 is 24. And when you multiply two numbers with like bases, you add the exponents. So this is going to be p to the -6, because -3 plus -3. We can't leave our answer like that, though. Leave the 24 on top, it's to the +1 power, and put the p to the 6th in the bottom. If this seems like a lot, I know it's pretty involved and it's pretty detailed, but you can watch this video as many times as you want. It just gets better. Alrighty, so let's go ahead and multiply this out. We would have 2 times 3 times p to the -4 times p to the -3. 2 times 3 is 6. Add the exponents. -4 plus -3 is -7. We must simplify this, so we put the 6 on top because it's to the +1 power, but p goes to the bottom and becomes a +7 power. Right? Over here, we would have 8 times 7 times v to the -3. 8 times 7 is 56. And this is v to the 1, and 1 plus -3 is v to the -2. So the final step to simplify this would be 56 on top, and we drop that v to the 2nd power to the bottom. Over here, we have a choice. We can flip-flop these two guys, or we can subtract -3 minus -2. It's up to you. I would personally flip them. I would put the n to the 2nd on top, and then have 4n to the 3rd on bottom, which you can do. And then we would have n to the 2 minus 3. So on the bottom, we have the 4, and n to the 2 minus 3 gives us n to the -1. All right, let me do this one again. I want to do it the way they would have done it too. Here we have n to the 2 minus 3, which is n to the -1. So actually that gave us n to the -1, and I moved it to the bottom to make it positive. If we had done it their way, this would have been 4's down here, n to the -3 minus -2 still would give us n to the -1, which we would then have to move to the bottom. Put a 1 over it. Okay. Are we having fun yet? We're having fun. All right, number 12. And this is my last example. I'm not going to keep doing these. I'm tired of them. Here, the 4 and the 5 don't reduce. So the 4 and the 5 are going to stay right where they are. 4/5 does not reduce. But we have n to the -2 minus 2. So n to the -2 minus 2 is n to the -4, and to fix that we have to drop it to the bottom, 5n to the 4th. All right, don't worry, we'll do a lot of examples of this in class. I know this is complicated, but I think you'll get the hang of it if you keep trying and you complete your practice assignments and you come to class. Okay, have a great week. I'll see you next time.